Hi everyone. So let's get going with theorem 1.0. So I hinted at a specific intuition which tells you that, all right, if n is bigger than 1 and n has no prime factors less than or equal to the square root of n, then n is prime. So the main idea is that if you have prime factors, so assume that the statement is wrong here. So that means that n has, so assume that there is no positive prime factors which is less than n while n is not prime. So what does it mean for n to be not prime? So it means that proof, if n is not prime, so that means there are factors, so there are factors other than n and plus or minus n and plus or minus 1 that factor n. So that means we can represent n as a multiplied by b. Right? So if n has a factor where that factor is less than or equal to the square root of n, then let's say that a and b make up n, right? You can subdivide a and subdivide b into its prime factors and say that without the loss of generality, that you can assume that just a is less than the square root of n has no positive prime factors, so assume that is true. So every prime factor is bigger than the square root of n. So that means that this is strictly bigger than the square root of n and the square root of n. So then this means that n is bigger than n. And so the reason is just because of the assumption that you had started out with, which is the assumption being if n has no positive prime factors less than or equal to the square root of n, so that means that every prime factors, in particular every factor that we can cut the number into, is bigger strictly bigger than the square root of n. So that means their product would be equal to n, and we get a contradiction. So the way you can visualize this is that if you have a prime p, where that prime p appears in the multiplication of a and b, then of course it will be bigger than or equal to the like it would be not, it's not gonna be bigger than or equal to the middle point, so to speak, of n, because otherwise it would mean that you get this contradiction here. So that's the main point, the intuition. So yeah, so let's so this idea is useful to calculate if a number is prime or not. So we'll start solving problems from the next video. I hope you guys enjoyed this video here, and yeah, like we'll talk more when I solve problems. See you guys.